All right, today we're going to be talking about modeling with functions. Specifically, we're going to be talking about independent and dependent variables. So go ahead and label page 28 to 3.3, modeling with functions. And then we are going to get started on independent and dependent variables. We're only going to do 28 today. 29 does have the same title, but we won't do that one today. So if you've got this, fold it in half. And we're going to be talking about independent and dependent variables today. I'll get my highlighters out. You're going to want some highlighters. Okay, so a variable whose value depends on another variable is a dependent variable. Today, we are going to highlight dependent variables in green. A variable that does not depend on other variables is called independent. The independent variable is going to be in orange today. All right, we are going to circle the statement below that is correct. It says circle. I'm actually going to highlight it in a different color. I'm going to highlight it in pink. So instead of circling, I'm going to highlight it. Okay, how far I can drive depends on the amount of fuel left in my car's tank, or the amount of fuel left in my car's tank depends on how far I can drive. We have to decide which one is correct. If you're driving, does the amount, how far you can drive, depend on the amount in your tank? Or does the amount of fuel in your tank depend on how far you can drive? The first is true. How far I can drive depends on the amount of fuel left in my car's tank, because I can only go as far as I have gasoline. So the other one is not true. We're going to kind of cross that one out. That one's not true. Okay. Given that the dependent variable depends on the independent variable, okay, that's going to help us today. The dependent variable depends on the independent variable. Identify the dependent and independent in this situation. I'm going to kind of box those in then. The dependent variable, how far I can drive, depends on the amount of fuel left in my car's tank. So I'm going to write that. The dependent variable is how far I can drive. The independent variable is the amount of fuel left in my car's tank. Okay. Now, something else to know. The independent variable is always graphed on the x-axis. The independent variable, I just did that wrong, of course I did. The independent variable in orange is on the x-axis. The dependent variable in green is on the y-axis. So the independent variable, how far I can drive, which is the independent variable, the fuel left in my car's tank, is down here on the x-axis. The distance I can drive, distance, is on the y-axis. Now, we are going to graph this. If I have no fuel in my tank, sorry, it's the amount of fuel left. If I have a lot of fuel left if I have no fuel left, I cannot go very far. So I'm right here. The more fuel I have, the further I can go. So here's my graph. The more fuel I have left, the further I can go. All right, open this up. We're going to identify some more and graph some more. Okay. We have all these statements, okay? And we are going to graph them, fill them out, decide what's going on. Statement 1. Oil and natural gas is a major part of Oklahoma's economy. Oil and natural gas producers tend to pump more when oil and natural gas prices are higher, and less when prices are lower. We need to think about what depends on what. So we have a couple things going on. We have the price of the oil, the natural gas, the oil and natural gas, and we have the pumping frequency, like pumps more or pumps less, okay? So we have to think about which one depends on which. So they pump more when the price is higher. They pump less when the prices are low. Okay? Our depend statement. Pumping frequency, how often you pump, depends on the price. Okay, so we're just going to rewrite that. Pumping frequency depends on price. And the reason we have written that is so that, make sure I highlight it right, we have separated it into the dependent and the independent variable. The independent variable goes down here on the x-axis. The dependent goes on the y-axis. Okay, so pumping frequency and price. So price, pumping frequency. Pumping oil and natural gas is something that continues forever, like it's a continuous graph, okay? And it says over there that they pump more when prices are high. So they pump more when prices are high. So that looks like that's up here somewhere. They pump less when prices are low. So it looks like it's just going to be a continuous graph. It's going to increase as the price increases, the pumping increase is going to increase. So there's our graph. Okay, the next one. Drumright's senior class is planning an overnight trip to Six Flags that will require a hotel stay. The more students who go on the trip, the more hotel rooms they will need. So what depends on what? The hotel rooms depends on the students going. So the more students that go, the more rooms they'll need. If they have less students, they'll need less rooms. So rooms depends on students. Okay, and we're going to graph it. Students, rooms. Okay, If you have just a few students going, you don't need very many rooms. But the more students that you have, the more rooms that you will need. So the more students we have, the more rooms that we'll need. Now let's talk about this graph and why it looks like this. I have just individual points because a hotel will not let you have a half a room or something of that nature. You have to buy rooms in specific points, okay? Also, do you notice how it doesn't increase if I got 1, 2, 3 students? I just need, let's say, 1 room, okay? But then when I've got 4, 5, 6, I need 2 rooms. If you've been on a school trip before, they don't get 1 room per student, right? They make a couple of students stay in a room. So that's why it probably is going to look something like this. All right, the next one. On a road trip to Disney World, Billy asks, "Are we there yet?" His father answers, The amount of time we have left to travel is based on, ooh, I like that word, the amount of time we have already traveled. He already told us what the independent and dependent variable were based on the word based. Depends and based can be interchanged. So he said, time remaining depends on time traveled. Time remaining is the dependent variable because it depends on the time traveled, the independent variable. And let's graph it. Okay. Time traveled time remaining. In the beginning, on a trip, you have not traveled, you haven't spent any time traveling, which means you still have a long way to go. If we go to another time, I've traveled a little bit further, well, I don't have as much time remaining, but I still have a lot. I then continue to go down until my time remaining and my time traveled, I've traveled all the way there, and I don't have any time remaining. Now, this is actually a continuous graph because time can be measured in up to any kind of second, okay? Time can be traveled at any point, so this is a continuous graph. Okay? Let's look at the fourth one. Mrs. Carter begins baking brownies for Cookie Club at the last minute. The number of brownies that Mrs. Carter can bake is determined by how many sticks of butter are in her fridge. Here's another special word I like, determined by. Depends and determined by can be known as the same thing too. So number of brownies, I'm going to use the number symbol. I don't want to write number of brownies. Depends on number of sticks of butter. Brownies depends on butter. Butter and brownies. All right, let's think about it. If I have no butter, I cannot make any brownies. If I have, let's say, 1 stick of butter, I can make some brownies. I've got 2, I can make some more. 3, I can make some more. 4, I can make more. So basically, the more butter I have, the more brownies I can make. This is continuous since I don't have to have butter in full sticks. I could have half a stick of butter and make half a pan of brownies. I don't know what the ratio is to butter and brownies, and depends on what recipe you're using. But I could half a batch of brownies. I could make just one brownie if I'm really feeling like it. But so I could have any number of brownies. All right, last. Mr. Carter is creating a schedule for parent-teacher conferences. The length of each conference will be based on the number of parents who request a conference. There's my word based. So length of conference, I'm not going to write of conference, depends on number of requests. The dependent is the length of the conference. The independent is the number of requests. Okay, so let's graph this last one. The number of requests, not that you can see what I'm writing, and the length. If I have, let's say, just one request, I could have a very long conference with a parent. But if I have 2, I have to kind of split my time. If I have 3, I have to go further down. If I have 4, further down. 5, 6, 7, 8. Eventually, it kind of just bottoms out here because it gets to start being where it's just like, you know, if you had a whole hour, but then you have to get, you know, to this one, then I half it again and half it again. It eventually kind of just gets to where they're almost no time at all, depending on how many conferences you have to have. All right, the number of requests, this graph is going to be just the points because I'm only going to have requests in whole numbers. I can't have them any other way, okay? All right, we will continue to talk about dependent and independent variables tomorrow. It also is on your homework this evening. You need to glue this in on page 28. We will do page 29 tomorrow. After you have glued it in, or you wrote on that page, I will see you tomorrow.